This time we're going to take a look at a population mean confidence interval. And to do that, I need a data set description. And oh yeah, that coffee maker does. If you're not used to those Keurig coffee makers, they're a little weird. Oh, there is a coffee machine in the other room if you need coffee. Go help yourself. All right. So mindset matters is the one I want to take a look at here. I brought this study up before in some videos. So in this study about mindset matters, and you can go read this yourself. I'm just going to give you my version of it. A psychologist went to some hotels in New York and randomly selected a bunch of the workers in the hotel that cleaned the rooms. And they randomly selected some of that group to be told that the Surgeon General says if you want to live a healthy life, then you need a certain amount of physical activity in your life. And this psychologist told these workers that the work they do meets or exceeds the Surgeon General's recommendations for an active, healthy lifestyle. So they were told the work they do makes them healthier. The rest of the group were told nothing. They just said, hey, we just want to take some measurements of you, like your weight, your height, your blood pressure, and there were a few other things they measured. You can see the list of things they measured here. And they did those measurements at the beginning, and then they did them again 2 weeks later. I think it was 2 weeks, let's see. Yeah, 2 weeks later. No, I lied, 4 weeks later. Okay, they measured them 4 weeks later. So what I want to look at right now is the group of hotel workers that they were told your work is healthy for you, right? It's going to make you a healthier person. And I want to look at what was their change in weight. Did they lose weight? Because we expect if usually people are believed to be a little overweight, right? There's this large obesity epidemic in the United States. And so mostly on average, people are overweight compared to what doctors think they should be. So I'm hoping that if the belief that your lifestyle is healthy would help these people lose weight just by being told that, okay? So will I see that in this data? So I went and grabbed the data set, and I took part of it and I jammed it into this third tab here. So if you are watching this video in the future online, check out the description of the video. There's a link to the spreadsheet. For those of you with me live now, hopefully you have this tab still available to you. Now, what I did is I took the weight 1 and weight 2 and I made a new column called weight difference. And there I just simply subtracted their second weight from their first weight. Okay, so if their weight went down, I'm going to get a negative number. If their weight went up, I'm going to get a positive number. And if the weight didn't change, I'm going to get a 0. So those are all the numbers, and we see positives and negatives. The first column here, it was whether they were told their lifestyle is healthy or not. So 0 means they were told nothing. If I scroll down, you can see the highlighted ones. There's some weird highlights there for some reason. Oh, I know what went wrong. Okay, I'll fix that later. So the ones are the ones I want. So what I did is I just took these numbers right here and I calculated some of our standard summary statistics based on that. So that would be down here. So I counted the number of ones. There were 42 of them. And then I counted the average change in weight for the ones. Those are the people who were told their lifestyle is healthy because they do that job. And I got an average of negative 1.766. Right. So what I could say is that on average, people that believe their lifestyle is healthy and are thinking about it will lose about 1.776 pounds over 4 weeks. Right. On average, right? Some people gained weight, some people lost weight, some people didn't change. Now, I have a number here called a standard error, SE. I'll explain SE in a minute. I'm going for a 95% confidence interval. And I used StatKey to help me calculate that. And there's 2 ways to do that in StatKey. One way, oh, Celine forgot to remind me, blow this up. One method of using StatKey told me that the margin of error was 0.87. So that means I have 0.87 to the right and to the left of that negative 1.776. The other way of using StatKey, by using the StatKey upper and lower numbers, that told me that the margin of error was 0.844. They're similar, but slightly different. Okay, and I'll explain those 2 techniques in just a sec, but they both involve going to StatKey. When we use StatKey for a proportion, we only needed the count of favorable answers divided by the sample size. If you want to use stat key for a mean, you need all of the numbers. So for me to pull this out on stat key, and I should just hide these guys maybe. I can't. I need to highlight, so the first one is right here. I need the number 2.6 and below. So I'm just gonna, you could try this too if you want with me, if you have the spreadsheet in front of you. So I'm gonna highlight from that first 2.6 for the number 1 here. Sorry, I messed up the highlighting, all the way down to the last number in that column. Those are the differences in weight I'm looking at. Negative means they lost weight, positive means they gained weight. I'm gonna copy that. I'm gonna go over to stat key. Now, we're not doing a proportion this time, we're doing a mean. So I'm in the confidence interval column. I want CI, confidence interval for a single mean. When I get there, I want to then edit their data out. And I'm just going to delete their data and paste my data in. And just a note, when I pasted mine in, the first number in my list is 2.6 and the last number -3.8. Did I copy a heading that says these are the weight differences? No, so I need to uncheck that box. Otherwise, it'll take the top number and say that's the name of the data, which means I'll lose a number from my list. All right, so I'm gonna hit okay. It puts my numbers in there and it says there were 41 numbers, so it looks like I miscalculated before to fix that. And my mean is -1.785. All right, let me fix that. I must have accidentally copied that other highlighted number when I shouldn't have. So there are actually 41 people that believed their lifestyle was an active, healthy lifestyle, -1.785. -1.785. Now, to get the standard error or to get the confidence interval, then I have to run thousands and thousands of simulations of this study. And so again, what's going to happen this time is Stacky is basically making 41 slips of paper. On each slip of paper, it writes one of those numbers on it, puts them in a hat. And then if I create one sample, it then pulls out of the hat, looks at the number, puts it back in, it does that 41 times, writes all the numbers down and finds the average. So in my new sample, I got an average weight difference of -2.098. If you run it, you'll get a slightly different number there. Now, I don't want to just redo this study once. I want to redo it thousands and thousands of times. How many times should you do it? At least 6,000. And this is going to slow down my computer because that's a lot of calculations. All right, I just went for 7,001. Okay, what do I have in the middle? If I look at the bottom of my graph, I got a -1.788. Is that the same as my sample mean? No, it's close though. My sample mean was -1.785. So when I go to write my results down, I'm not going to go with this number down here in the middle. I'm going to stick with my number as my point estimate right there. So that's my sample mean. That's also my estimate of the population mean. Next, we want a two-tail graph, and StatKey will automatically put 95% in the middle. Why 95%? It's popular. Could I be 99% confident? Sure. I would just go in here and replace the 95 with a 99, but we're going to go for 95. So there are some homework problems where I'll say, hey, be 90% confident this time. And then you'll go in here and you'll change the 95 to a 90. Maybe I'll say be 98% confident. And then you go change the 95 to a 98. All right, now will we get the exact same numbers? No, we'll get close though. So if you were running this along with me with the same set of numbers, then you should have numbers that are pretty close to mine, not too far away. Okay, so what I'd like you to do is on a piece of paper, draw that bell-shaped graph that we drew before and start labeling it with the numbers that you found or the numbers that you see I found here. So I'm going to screenshot this sucker and I'll explain again what everything means on the screen here, how we use it. Let's see, add to new page, please. Shrink this a touch. All right. So again, whenever I do a new one of these on my paper, I drew a hand-drawn sketch of this by making myself a little x-axis, making my best bell-shaped curve. And I like to put that line down the middle. And that's where I put my sample mean in this case. Mine was negative 1.785. So I'm going to go with my sample number, not the number in the middle on StatQ, which will sometimes deviate. And I'm going to put my marks on the right and the left, make a note that I'm doing a 95% confidence interval, as opposed to a 90% one or a 99 one or a 98, and then mark those numbers that you were given or I was given. So on the left, I have negative 2.678, and I have negative 0.937 on that side. And a reminder, what is this a confidence interval of? This is a confidence interval of the average weight change of hotel workers that believe their work is healthy. Okay, so we're finding here confidence interval. So we always have to know what the data means, otherwise we can't say anything about it. Confidence interval for the average weight change of a hotel worker who believes their work is healthy. So next thing I need to do is I don't have the margin of error on here. StatQ doesn't give you that, you have to find it. Do you remember the best way to find it? It's to find the difference in the endpoints and divide by 2. So right now, I believe that the average X bar, which is approximately equal, does anybody remember the letter we use for the population mean? It's a weird letter you don't see often. It's a Greek mu. So mu, it looks like a cross between an M and a U. That's called the Greek mu. That's the population mean. What's the population here? Well, based on this study, I could say it's all hotel workers in the United States, because we're talking about the US Surgeon General and they were only hotel workers that were surveyed here. You might extend it to all workers in the US, right? So again, it's hard to say what the population is sometimes. I'm gonna go for all hotel workers in the US is my population. So what I believe is that if you told all the hotel workers in the US that their work is healthy, within 4 weeks, you would see an average weight change of negative 1.875. On average, they would lose about 2 pounds over 4 weeks. Cool. Most people want to lose weight. Not everybody, but some. Now, margin of error, ME. Best way to get that in StatQ is to take the upper number, subtract the lower number, and then divide that by 2. All right, so I need a calculator for that. Calculator. I'm going to pull this off to the side to do a calculation. All right, so I got slightly different, and every time I run this simulation, I get slightly different numbers. They're not always going to be exactly the same, but they should be in the ballpark. So my lower here, last time I got negative 2.617, but I think there was an error in my data that time. I think I miscopied. This time I got negative 2.678. And positive, or no, still negative 0.937 for mine. Yours may be a little bit different. Okay, that gives me a width of 1.741, and if I divide by 2, I get 0.8705. So for my numbers, so mine was the negative 0.937 minus negative 2.678, all divided by 2, gives me an average distance from the center of 0.875, or 8705, sorry. What is that a number of? That's a number of pounds, because the mean was a number of pounds. So what I'm saying is I think the average is about a loss of about 1.8 pounds with a spread of about 0.9 pounds roughly. Okay, so if I rounded these numbers a little more, you know, the negative 0.9, I might call that about a loss of about 1 pound. And maybe the 2.6-ish, maybe I could call that 2.7 pounds. So on average, I expect people to lose somewhere between 2.7 pounds and 1 pound if they believe their lifestyle is healthy over 4 weeks and they're really thinking about it. Now, here's something interesting to note. Was there on average no change in weight for these people? Well, if there was no change in weight, that means their weight before was the same as the weight after, and the difference would be 0, right? Is 0 in my interval? No, 0 is not anywhere in this interval. It's way off to the right, right? Let's think about the scale here. Looking at stat key, let's blow this sucker up. This is in pounds. Ooh, is it in pounds? I think it's in pounds. Let's see. It wasn't done in New York, I believe. Most of the hotels were in New York, if not all of them. Weight in pounds. Yep, it is pounds. All right, so let's see. Where was I going with that? Oh, I wanted to just double check this measurement here. So let's copy this, put that in a new page and blow it back up. All right, so here is -1, here's -0.5, so 0 on average losing no weight, that's somewhere over here. Is that anywhere close to being in my 95% interval? No, that's pretty far outside. Well, somebody might say, well, make the interval wider. Okay, let's be 99% confident. You can never be 100% confident. That means you survey the entire population, which ain't possible. Okay, so 100% is impossible. So I could go back to stat key and say, can you please give me a 99% confident interval? So 99 as a decimal, 99% would be 0.99. Okay, it's gonna oops. Try it again, 0.99. Uh-oh, I broke it. Oh, ooh, oh, I screwed something up, huh? Eek. All right, let's turn that off. Turn it back on. I must have clicked on the wrong thing. 0.99. There we go. Okay, so now it goes out here up to negative, losing on, it could be like -6.875. Is 0 in a 99% confidence interval? No. So are we very confident that on average people lost weight in this study if they thought their work was healthy? Yeah, we think it was, because 0 is not in the interval, right? So now we're using a confidence interval to get into the idea of what's called a hypothesis test, where somebody says, hey, if we tell people their work is healthy, on average, they're going to lose weight and be healthier. Really? Can you prove that? Not 100%, but pretty well. I can prove with a 99% confidence interval that on average, people did lose weight. What's the chance that people wouldn't lose weight? Well, that would be the chance of 0 being in this interval, which is pretty remote possibility. I don't know, maybe it'd have to have a 99.9999999% confidence. When you up your confidence level, you widen the interval. What's the problem with widening the interval? Well, then you make the margin of error bigger. Does it sound good to have a big margin of error? No, right? So you can be more confident, but that's going to make the margin of error bigger, which makes your confidence interval look worse. Okay, well, how do you increase the confidence and decrease the margin of error? Only one way to do that: substantially increase the sample size. The only way to narrow the interval is to increase the sample size or lower your confidence. Let's be 60% confident. Is anyone going to pay attention to us if we're 60% confident? Nope, they're going to say, please go get a day job. So, okay, what's the problem with making the sample size substantially larger? Time and money, right? It costs money to do this stuff. So there's all these trade-offs there. All right, let's see if we can write a sentence for what we just calculated here. So remember how we wrote the sentence for the 95% confident, we have blah, blah, blah for the percent of people who thought Russia was an enemy. I'd like you to try and write a sentence for what we just calculated. And so that would look something like, instead of for a proportion, it's for a mean. But here was like the general theme. I'm 95% confident that, okay, what does our variable mean here? Our variable was the average weight loss. And then we have to pick one of those options to finish it. So take a stab at writing a sentence about what we just calculated based on either, oops, where'd it go? Here. You could use either the endpoints of the interval to describe it, or you could use our center and margin of error to talk about it. So give it a shot, and then I'll write my sentence down. Let's see how good we do. And this is a mean, right? It's a little different than a proportion. So the sentence is going to be slightly different, but give it your best try. There's many ways to write this. Sentences always start out the same way. We are 95% confident that, then comes the hard part. Okay, so something to think about in the sentence here is so bottom line, right? I'm 95% confident that the average weight, now am I saying weight change, weight loss, weight gain? I got to think about how I word that, because that depends on whether I state my numbers as positive numbers or negative numbers. So thinking about, like, I like to think about my mom, what would I say to her about this, who's not really into math or statistics? I would probably choose to say weight loss, since all of my numbers were negative. If one side was negative and the other side was positive, I would probably say weight change to deal with the positive negative problem, right? So every situation is different. And then I would say, since I'm putting the loss here, I don't need to use the negative. So I'm going to say I'm going to go to one decimal place. I'm going to say 0.9 pounds and 2.7 pounds about was what I had for my other one. If you use the word change there instead, then down here, you would have to put negative and negative on those two numbers, right? You'd have to be specific about that. And that's just a choice in the way we write stuff down, everybody has to make. Alternatively, you could have gone for my option 2, which would be to say something instead. So after the is here, so this is option 1, option 2 would be to say something like is about 1.8 pounds if I go to one decimal point with a margin of error. You don't need to put both of these ways, just pick one. What do you like better? I usually state the interval like this when I'm doing this one. And then when it comes time for the press release, I'm just going to say, hey, we think the average weight loss is about 2 pounds, right? I'm going to do it that way. Margin of error of about, and what did I get? 0.87-ish. So maybe I'll call it about 0.9 pounds. All right, so one more note about this, I'm going to shut up and do a different problem, is if I look back at the stat key graph, stat key gives me a bunch of statistics on this page. It tells me how many samples I did, and I did 7,001 samples. Maybe you did a slightly different number of samples. Okay, so and on the screen here, each dot represents the mean of one of those 7,000 samples. It's also telling me what the mean of all of these dots on the screen is. And it's giving me a mean of negative 1.788. That's a little bit different than the sample mean I started with, which was a negative 1.75. And typically when I'm stating the center of my results, I use the original sample. So notice when I was writing down on my paper, I used the negative 1.875 right here. Come on, highlight please. Anyway, the original sample mean instead of the mean of the histogram here. Next thing I didn't talk about, but I mentioned it, is standard error. What is standard error? Well, every set of numbers, in this case, I have 7,000 sample means on this screen here, I can calculate the standard deviation. So the computer took those 7,001 averages it found, and it found the standard deviation of all 7,000 of those, and it found the standard deviation of these dots here, Chrome does not like stat key today, was 0.443. So the standard error is the standard distribution of the sampling distribution. Complicated and weird. There are 3 different standard deviations floating around in the world right now related to this problem. One of them is the standard deviation of my sample, which is 2.882 up here in the upper right. Yeah, the standard deviation of the sampling distribution depends on the sample size. And we'll look at the relationship between the two of them in 3 weeks. We'll get to that theoretical result. There's also the population of weight changes of all hotel workers in the United States. They have their own standard deviation. I have no idea what that is. Right, so there's 3 standard deviations floating around with this problem. 1 is the one from the sample. 2 is whatever lives out there in space, no idea. And 3 is the one on StatKey's graph. That's called the standard error. The 95% rule says how many standard deviations is that to each side of the middle? 2, right? If you double the standard error, that's going to be approximately the margin of error for a 95% confidence interval because of the 95% rule. So I just want to write that down. That's the last bit of fact. Everything else is practice. So new page, standard error is the standard deviation of a sampling distribution. The standard deviation of a sampling distribution. Please read section 1 about what a sampling distribution is. And in this instance, what does a sampling distribution mean? It's a histogram of sample means. Of many sample means. And if we use the 95% rule, then the margin of error is always going to be approximately 2 times the standard error. If you go for any other percent, like a 98% confidence or a 90% confidence, it's not 2. It's some other number. We'll talk about that in 3 weeks. So if I double that 0.44, I get 0.88, which was about what my standard error came out to. Mine was 0.87, right? It's in the ballpark. So if we go for the 95% rule, then StatKey gives us 2 ways to come up with the margin of error. One is just double whatever it says the standard error is on the top of the screen. The other, to get the margin of error, is to take that upper value of the confidence interval, subtract the lower number, and divide by 2. Will they be identical? No. This is a simulation. Weird shit happens. But it's all similar stuff. Okay. So again, we're doing confidence intervals via computer simulation. StatKey is the main tool for that. Are there other programs that do this out there? Yep. but we're not going to do those. Stack key is pretty easy to use. Your homework problems are about 3 topics, really. One is, what is a sampling distribution? How is it different than a regular distribution? That takes some getting used to. 2 is, can you go back and forth between talking about a confidence interval by using the endpoints or the center and the margin of error? Getting used to that relationship. And 3, given a situation, can you create a confidence interval by going to stack key and giving it the data it needs, right? So do your best on that. The application for this week is very much like this problem we just did, very much like this one. And I'm going to post this recording for you to look at. And I have another similar recording to another situation like this. Check it out.